Okay? Shabab, with regard to this section view, okay, I will record this video and I will show it to you on the share it on LMS. Okay? As you can see, this is the part. What type of section I told you to do? What type of section view? What we call this section view? If I want to cut the part and the feature, they are not straight on the same line. In this case, this feature, this hole, called feature, this hole, this slot, they are not on the same line. So I have to move like this, like this. See, this is the result. I have to cut not straight in different lines. So what we call this type of section view? Offset section. Bravo. Okay? Offset. So we have to go horizontal, vertical to reach all the point, all the features, all the holes that we want to get. Okay? So this is example. How to tell when I cut this offset section, how can I see the part inside? You have to be direct parallel to this part, like this. So you will see this line, 2 lines, and this hole, and see from here, for this slot, you will see this line, down. Okay? So this is how we look to the offset. Okay. Today we talk about dimensions. Okay? Dimensions. So what's the objective? Use conventional dimension technique to describe size and shape accurately, using drawing, create and read drawing at specific scale. In order to understand the dimension, you have to be able to create and read the drawing. Not only read dimension, also you have to know the technique to apply the dimension. Okay? So correctly place dimension line, extension line, and angle. We study in the first lecture about type of lines. There is dimension, extension, nodes, leader, like this. So in this lecture, we have to know exactly how to make dimension line, how to make extension line. Is there any conditions or any rules to apply this? Dimension for the circle, arc, and inclined surface. Apply finish sample, dimension contours. Use standard practice for dimensioning prisms, cylinders, hole. Okay, list practice for dimension solid model. Identify guideline for do or does and don't do. Okay, so there are something you have to do and something you don't have to do for when applying dimensions. Okay. So first step, if I ask you dimensions, when we apply dimension for what? For the drawing. So, what type of features we do? Smart. Let's say like this. We have part. Here's hole. Okay. I'll apply dimension now. That's it. I want to apply dimension on this part. I will apply dimension for first from here to here. Okay. Let's say this is 100. And this, and then from here to here. Let's say this is 60. And then I want to say what is the value of the diameter of the circle. Let's say 520. What we call these dimensions? If I give you this part has width 100 and has depth 60, and this hole has diameter 20. What I'm giving you about this part? What do you think? I'm giving you information about what? Bravo. About size. I'm telling you the size of the workpiece is 100 by 60, and the size of the hole is 20. So this is called size. Now there is other dimension which is called location. See? If I tell you this hole from here to here is 80, and from here to here is 20. Here what I mean is center line, like this, center line. Center of the hole. From the center of the hole to the edge 80, from the center to down 20. This is called location. Okay? So usually when we are doing dimension, we are doing dimension for two things. Size and location. See? Size of the fillet. size of the hole, size of the part depth, size of the width. This is size. Now location. Location from here to here, from here to here, from here to here, from here to here, from here to here. That's why this is easy guide for you. In the final exam, or in the exercise, when I give you apply dimension for this part, I will give you part without any numbers, without any dimension. You have to apply dimension from your own. Measure the part and put the dimension. Okay, so you will say, maybe I will forget dimension. So make this as your reference. You have to apply dimension for size and location. Yeah, come here. This size of the hole, we know. This size of the hole missing, so you have to make dimension for the size. This hole missing. Location, from here to here, you have to identify. From here to here, you have to identify. From here to here. Now from here to here, from here to here. Once you finish from size and location, the dimension is finished, ready. Okay? So, like this is an example. Whenever the part is complicated or has more features, cone, cylinder, it's all about size, 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 and location, 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 location. Okay? See, like this one. This cylinder has to identify the size of the angle, the size of the small diameter, the size of big diameter, the size of this fillet, the size from here to here, the size from here to here, the height. Okay? So, technique for applying good dimensions, we have standard appearance, line, spacing of the dimension, size of the arrowhead, then placement of dimension. Use logical placement for dimension according to standards so they are legible, easy to find, easy to read. Choice of dimension you choose affect how design is manufactured. Okay? For this simple example, it will be like this. See, if you have one more time like this, okay, height, hole, you cannot do like this. What do you think wrong about this drawing? See? Size of arrowhead. All mentioned. They are all rules. Okay? You cannot make the size of arrowhead exceeding the size of the text and exceeding even the features and like this. The size of the arrowhead should be percentage. Okay? From the text, like 80% from the text. So the text like this, the size of arrowhead, and it should be like this. Okay? What else? Standard spacing of dimensions. You cannot make the dimension as an example here. This area, this distance, has to be relative to each other. Okay? Maximum like 1 cm, 1 millimeter. Also it has percentage. We will show you later how to make it close enough to tell that this is related to each other. Okay? Placement, use logical placement for dimension according to standards so they are legible, easy to find, easy to read. This is very important. When you have more than one hole, you cannot do like this. You cannot, let's erase it. You have like this part, you have hole, hole, hole. You cannot do like this. One time from here, 10. Then from here, 20. Then from here, 10. Then from here, 10. Then from here, 20. Then from here, 15 or like whatever. You cannot start the dimension one time from left, one time from right, one time from left, one time from the bottom, one time from top, one time from top, one to the right side, one to the left side. You cannot do this. In order to get appropriate dimension, you have to make the dimensions for the same component. As an example like this, see? One time here, other dimension here, if you choose this one to be the baseline for you, and here. See how organized it is? So now you can read it. Okay. See, if they are on the same line, you can make one dimension here and one for this one. Now anyone can read this drawing instead of having right and left. Okay? The last one, the relation between features. Sometimes you have part like this one, as an example, 2 holes. And this part, this workpiece, has to be fit on other part which has 2 cylinders. So I want to put this part on this part. Okay? So I cannot, in this area, come from here and say the dimension from here, like 10, and the dimension from here, 10. I use this edge, and I use this edge. Okay? And here, in this part, I say the dimension from here to here is 10. Okay? I want to ask you, in the top drawing, what's the dimension between the 2 centers of the holes of the cylinder? 10. In the bottom one, what's the dimension between the 2 centers of the circles? We don't know. What if this part is 40? What will be the dimension between the cylinders? لا, if this 40, من هون 10, من هون 10, what will be in the middle? 20. So you cannot say, I want to take dimension from here, 10 from it, and ignore this value if the total is 40. Because I want them to be 10. So you cannot say like this. So what you have to do, you have to dimensionally show affect how your design is manufactured. This method requires through understand of relationship between features. You should understand what's the relationship between features. What I care about? I care about the distance. Okay, خلاص. I have to do like this. 10. High, whatever the part is. ممكن high part تكون long, very long. I don't care. I care about the distance between this because I want them to be fit here. Okay? So this is the last technique. Any question about this anymore? If I give you something like this, in the final exam or in the lab, I want you to measure it and apply dimension. You should not keep it like this. You should make section view. Because here, any part that does not show the internal holes, you have to cut the part. Okay? So without telling you that this is section view, as an example in the final, I might not tell you, use section view to show me this dimension. You have to do it by yourself because in this case, can you see the hole from inside, from here? Can you see the holes? You cannot see them. So you cannot apply dimensions. This is rules, I'll show you now. Okay, so see we have good, no, no. As you can see, now from here, you will see something like good, no. I want you to just tell the difference between them. See here? Let's start with this one, no. What we are doing here, applying dimension inside the view. Applying dimension inside the view, which is incorrect. Don't apply dimension inside the view. What we did here, we erased the extension line. Extension line has been erased. You should not do this. Okay. What we have done here, we cross the dimension. See, if you have part like this, similar to this part, I will draw the same. You cannot do like this. You cannot do the dimension from here to here is 100, and the dimension from here to here is 50. What we did, we made the dimension for the small feature outside and the dimension for the big feature inside. The result, we have intersection, which is wrong. The good, how to correct this one, when you have part like this, you have to make the dimension for the small feature inside, 50, the dimension for big feature outside, which is 100. خلصتوها؟ خلص اوكي؟ يلا هاي don't apply dimension for big feature or long feature before small feature. You will have intersection. See, don't cross dimension. Okay? What you have to do is you have to make it like this. Make the small feature first, then later make the long feature. Okay? ليش؟ لأنه الdimension it's required to have extension. In this case, the extension here and the extension here, they did not cross. But if there is a small feature and you want to get it dimension down, where you have to draw the extension? Here. So definitely you'll get intersection. So that's why they are telling you don't draw dimension for small feature, outside dimension for the large feature. Okay, let's finish. Let's continue. This one, dimension for leaders. Leaders, you don't have dimension from to. When you are doing leader, you don't have dimension from this distance to this distance, because dimension for leader, not for distance, not for location. It's only for size. Like this. You have this pattern. You are saying pitch 0.8, the distance between them 0.8, raise diamond, the shape diamond. Here, you want to say polish this part, make grinding or polishing or like this. So you have to use leader. How to use the leader? Use one line and then you do like this. This all the time 45 degree or 30 degree or 60 degree, this angle. So you have feature, draw arrow, draw line with 45, then be horizontal and then add the value. مثلا 510 like this. High hole 510, diameter 10. So this is not location from here to here, because there's only one arrow, so this is size. I'm saying this hole has size 10, so this is called leader. Okay?
More than one hole, same
Size. Good example. If you have like this, high part, more than one hole, all the same size, like this. This one, this one, this one, this one. They're all the same size. You have to do one leader, only one, like this. Choose any one of them. Second one. You have to say 4 multiply diameter 5. So I have 4 pieces, 4 holes. Each one has diameter 5. This is how to apply dimensions. And this one will be explained just within 2 slides later. I will show you how to use this one. It is mentioned, okay? What if you have different, like this? One small, one big, one more smaller. You have to use 3. You have to use one for this one. But can you do like this? Cross. See here? Cross each other. Don't make that leader. Cross each other. Can you make the leader like this? 5, 10. You cannot make it horizontal or vertical. You cannot make the leader like this. 5, horizontal or vertical. You have to make the leader with angle like this. Like this. Like this. Like this. You have to make it with angle. Like this. Like this. Like this. With angle. See? Like, كل هذول leader. كله leader. This is the leader. Okay? Parallel to nebula, you don't have to do it through the corner of the view, and the corner 100%, cross each other longer than needed. You cannot do it like this. Horizontal or vertical, as I show you here. Okay? As you can see, these, you see it guideline. In the final exam, when I give you drawing, and I will tell you, apply dimension, I assume that you understand these rules. So you will do it. I will give you drawing like this. I will have top view, I'll have front view, I'll have right side, I have feature like holes, different sizes. So I will think, this one will cover the leader. This one will cover the dimension and extension if I have like this part. They don't have to cross the dimension. So I cover this one. So I will cover this one. That's why that's the way that we put the exams. Each rule here we told you about. So when we explain anything, take into account that this is a rule we have to worry about. There is 2 techniques for applying dimension called direction of the dimensions. Okay, one called unidirectional and one called rectangular coordinate. Okay, unidirectional. As an example, you start from here to here 17, from here to here 24, from here to here 14. Now we come to here 28. Then from here to here 7. Then angle, then line. So you don't have reference, right or left, up or down. You don't have a reference, which is okay. Which is okay if you don't have reference. In this drawing, mainly for part that has similar features. Yeah, in this, what you can see here, only holes. You cannot see angle, you cannot see slot, you cannot see anything, only holes. So they are using reference point like this. Now they are doing like this. This is the corner. They would say here 0, here 0. So if I have hole here, what's the dimension for this hole? Make line, and what's the dimension? As an example, 10. If you have hole here, make line 15. If you have hole here, make line 20. Whenever you go to the right, this is the distance from here to here. This is the distance from here to here. This is the distance from here to here. If you have here, this is the distance. But instead of having arrow, this will be too much long. So they did it in this way. And they did it in this way. See 0, the reference, then 5, 19, 30. Whenever you go to the right, the value is bigger. Whenever you go up, the value is bigger. Is this clear? For the holes, as you can see here, they don't use leader. Can you tell that? You cannot see leader here. Instead, they use symbol. C, and table. Whenever you see C, the value is 3.6. Okay, what's the value of D? 3.1, bravo. So instead of having leader, okay, when should I do this? If you have too many holes have the same diameter, like this, you have C. Instead of having leader 4 or 5 multiplied by, and here you have leader, and then here you have leader, and where is A, B, C, B, and D? Here you have a lot of leaders. Instead of having this, just you don't have to use the leader, you have to use the symbol. Clear? Okay. Poor to make them on the same line. Good to identify which number belongs to which feature. Poor to make the dimension inside the drawing. Leader and this one and this one. Good to make the dimension outside. Okay? Poor to have the dimension on the hidden line. Instead, you have to create section line. You remember about this part when I told you high hole, similar to this hole, high hole. You cannot make dimension hidden line. You have to cut, see from inside, this is visible line, add section lines, and then this will be section view. Then you can apply dimension in the section view. Okay? Here, who can tell me what's wrong, what's right about this? Why this poor? Why this good? Just take your time. I want to take like 1 minute, okay? Just look at the drawing and tell me what do you see. I want you to ask yourself, what is the dimension value of the hole? What's the location of the hole? What's the value of this height? What's the value of total height? What's the thickness? This is how I want you to ask yourself. Okay, who can tell me now? Yes. Start with. Bravo. For the hole here, it's given the dimension for the hole in the top of you in the hidden line. صح? And is the hole located in the top of you? The hole is located in the front of you. So you are using wrong view to represent the dimension for the hole. صح؟ مش أنا when apply I have orthographic projection, top, front, right side. Why I do top, front, right side view? Why I do this? ما سألت نفسك ليش أنا كنت أطلب منك تعمل top, front, right side? To apply dimensions. Later يعني إحنا درسنا الدرس مرة عشان نتعلم كيف نعمل top view, right side view. Later عشان نحط عليهم dimension. أوكي كيف أنت تعمل top وتحط الدايمنشن وهي الفرونت تحط dimension على التوب. So this is wrong practice. هون أنا بطلع حكاية two lines. I don't know two lines they are representing what exactly. Okay, what else? What's the location of the hole? And this hole, what's the dimension from the bottom to the center? What's the value? Huh? 54, but it's not located here. It's located on the right side of you. Also wrong. See here? The dimension is 54. The diameter is 22 in the same view. Okay, this is for the front view. Now let's see the dimension for the right side view. Okay. What's the dimension from here to here? What's the value? The height. It's given here 20 in the front, not on the right side. See here? The height is 20. It's given on the right side view. Okay, what's this 10 represent? If you see this hidden line has 10. What's this 10 you understand from it? Who can tell me what you understand from this 10? Do you know the answer? See, it represents the hidden line belong to this edge inside, because this edge from here to here is 10. But this should be in the top of you, not on the right side of you. See here? 10. Not here. So, each dimension is given on the wrong view. That's wrong. Remember this, it's not about applying dimension. You can apply dimension whenever you want. The software that you are using, if you click any place, it will give you the value of these 2 points that you click. But it's not about applying the dimension. You have to follow the rules. In this case, you have to give the dimension in the correct view. Like all features represented from the top, give dimension from the top. All features represented from the right side, give the... Imagine this one. I have this part, okay? I will tell you the dimension of this hole like this. I will catch it like this from side. I will tell you this is the dimension for the hole. This is the dimension for the hole. But if I give you like this, you would see it more clearly. I will tell you we have hole number 1, hole number 2, hole number 3. The dimension of this is 20, this one 28, this one 44. Is this more clear? But if you look from here, I have 3 holes. The dimension is, you cannot see them. That's why. Okay. You remember when you asked me about quantities? So this is the rule. Use X symbol for representing dimension, quantity. You don't have to use R.5, R.5, R.5. Instead, 4 multiply R.5. Because we have 4 of them. صح? Any questions? In this slide, we are saying all necessary dimension must be shown. You don't give unnecessary dimensions. You don't have to repeat the dimensions. See here, what's this value? 12 for the depth. You remember the rules of meter line? So this value will be repeated here. So you don't have to mention it again, 12 and 12. Because this depth is equal to this depth. So if you want to know, this depth is equal to this. So you don't have to make 12 and 12. One more thing. If this one is 16, the depth of the hole, you don't have to mention it like this here, 16. This symbol for the depth. الأرب. You don't have to say phi 6.3, depth 16, if you are using here 16. So you have to cancel this one and use this one. Also the same. Everything here is the same. 0.62, 0.62, 1.6, and the total. You don't have to do this. Okay? Like this one. See this example? Hole, hole. If I tell you from here to here is 5, from here to here is 5, the total is 15. What will be the distance from here to here? You don't have to write it. Okay? خلاص. You know that this is 5. Keep it in your mind. You don't have to write it, type it on the dimensions. This will be wrong, see? You don't have 0.62, 0.62, 1.24. You have the total, you have one of them, erase the other one. Okay? This is dimension for the angles. You can use distance and angle, 2 distances. it's okay, or angles. You can make the number inside the arrow, number outside the arrow, number and arrow inside the angles, or outside, it's okay. Dimension for the radius, you have to use the R. You can make arrow inside, arrow outside, dimension and arrow inside, it's up to you. Dimension for the counterbore split face. Do you remember when you talk about counterbore? See, we have two holes on plate. From the front view, this hole is this one. The small hole is this one. The small hole, like it's, let's say not this one, let's say 4. Small hole. The big hole, let's say 13. Okay, don't forget the 5. The distance from here to here is 7. How to represent the dimension? You don't have to type the dimension 2 times, one time in the front, one time in the top. Okay, but if you know that these are the values, erase them from here and type like this. Start from the small one. 5, 4. Okay? Through. Channel through, it's all the way through. مخترق القطع كامل. Through. Now, counterbore, you have to draw this symbol. Counterbore, what's the value? 13. Depth of this counterbore, 7. Is it clear? One more time. 5, 4, counterbore 13, depth 7. This is how to represent the counterbore. Split face the same, instead use this one for split face. See dimension for the circular pattern. When you have circle in the pattern, see how many holes we have here? 5. So 5 multiplied by 17.4. What's the distance between each one? They are equally spaced around the circle, so equally spaced. Okay? If they are not equally spaced, you have to mention the angle for each one of them. Or apply it in X, Y. Chamfer, you have to use either 3 to 45 degree or 3 by 3 chamfer. Any chamfer like this. 3 by 3 chamfer or 3 45 degree. What if it's not 45 degree? Okay, use the angle 30 or whatever. Okay? Dimension for the near pattern. Pitch point 8 raised diamond or pitch point 8 straight. We finish. Any questions about dimensions? Is it clear how to apply dimension? Now in the lab we will do practice, okay, for having the dimensions.